Welcome to today's webinar. My name is Ben Potter. I'm an application engineer here at Concepts in Production, and today I'll be showing SOLIDWORKS for cabinetry design. I'll be spending the next 30 minutes or so walking us through the capabilities of SOLIDWORKS for the cabinet and furniture industries. The first capability we'll be focusing on is intelligent design, where we'll look at how weldments and equations allow us to rapidly create cabinet designs. Next, we'll dive into automated modeling. Here we'll see how we can create features and components that help us automate our modeling process. Then we'll look at how quickly and efficiently we can take our modeling design and create detailed manufacturing documentation. We'll then see in optimized nesting how we can take our cabinets and create nests ready for our CAM solutions integrated directly into SOLIDWORKS. And finally, with integrated CAM, we'll see how after nesting, we can go straight into creating our G-code right from the SOLIDWORKS software. In intelligent design, we'll take a look at creating a cabinet face using weldments and talk about the benefits of weldment profiles. We'll also look at using equations to drive changes in the size of our drawer models. I'll walk us through the weldments as well as finishing the cabinet with more common SOLIDWORKS capabilities. Then I'll show what we'll call a template part, or a blank part, that I can then change and save out for use in other designs. While I'm in SOLIDWORKS, keep an eye out for how seamless and streamlined these operations are. Weldments utilize profiles along a path. These paths can be either 2D or 3D sketches, and the profile can be simple shapes or even irregular shapes, such as crown molding. In this case, we'll use standard sizes of 2x1 and 2x2s to complete our cabinet face. Going into the weldment feature, you can see how the profiles run along our 3D sketch. These points are the joints, and we can go into them and actually select how we want our joints to be connected, whether by end to end or a miter cut. We can also select which profile is the dominant one for the end-to-end selection. We can create groups based upon the direction of the path, and these groups allow us to go in and edit the different sections. A profile can have many connection points, and we can select how we want our profile to be oriented within or along the path with these connection points. Coming into our middle crossbeam, we can select the bottom corner and you'll see how it moves up. Now I'll set this back to the center and we can go ahead and get out of our feature. Now that we have completed the face of our cabinet, we need to go ahead and put in the side paneling, the support structure, as well as battens and bottom shelving. To do this, we'll use the common SOLIDWORKS capabilities of extrusions. I've created a sketch here, and we can go in and select the different contours of our sketch and go and extrude everything out nice and simple so that we now have a completed cabinet. Add in the doors with a final sketch, and we are done. Next, we'll look at equations. As I open up our template part for our drawers, we'll go into its sketch. The sketch is based upon the opening in which the drawer will be inserted in. You'll see two dimensions, this 5 and 7, have the summation, or looks like an E symbol next to it, denoting that they are controlled by variables or equations. From these, I can go into the equation dialog window and change their values. As I change these, we'll see when I rebuild these that the drawer will automatically change its size based upon the inputs to the variables that are controlling those dimensions. This allows us to create a simple template part and then make essentially an infinite number of parts based upon the sizes, whether it be custom or standard. Now I simply have to save this part as the product name, the part number, However, my company wants to denote these for a use in assemblies or drawings, and that now has been created, and I can continue to manipulate my template part into all the variety of shapes and size drawers that I need. With the intelligent design of using weldments and equations, we are able to save time. Weldments allow us to create and store a variety of standard and custom profiles, while simultaneously affording us the controlled precision that we can use to quickly complete our cabinet designs. Equations give us the power to create template parts that we can then quickly change to our desired specifications, eliminating the need to model each design variation. With automated modeling, sometimes we have designs and components that we use on a very consistent basis. With SOLIDWORKS, we are able to create smart features and smart components for these common designs and parts. Starting with an elevation plan or a cabinet layout, I'll walk us through how we can let SOLIDWORKS do the heavy lifting with smart features. And once I've created my kitchen cabinets, I'll show how smart components can be used to quickly add in common parts such as doorknobs. Throughout this automated modeling section, look out for the ease of use and efficiency when using smart components and smart features. Starting with our elevation plan or cabinet layout, we can go into the design library where we can create custom parts or parts that we use multiple times and store them here. Here we'll create our single door cabinet. Once we select the single door, we now need to select which configuration we want to use. This shows that we can have multiple types of configurations within our smart features stored within the design library. Here we'll select the multi-shelf, and then now we are given the preview window where it shows us which points on the layout we need to select to apply it. It'll be the lower back corner, the upper back corner, and then a point to define the depth upon which the cabinet will come out. As we see, the cabinet is automatically generated by SOLIDWORKS. If we spin around to the back, we'll see the shelving as well as the hole pattern for the adjustment to the shelves. This was all created when we created the smart feature and allows us to have more complexity within our smart features. Next, we'll add the double door cabinet. Again, it is the same workflow. We'll select it, select our configuration, then following the prompts within the preview window, we'll select the bottom corner, the caddy corner, upper corner, and then a point to define our depth. Now we'll do that one more time to finish up these two inner double door cabinets. On the last single door, we'll follow the same workflow, bottom corner, upper corner, and then a depth. But this time, when we select our configuration, we'll do a single shelf configuration. Spin around once it's created and show that we now have only one shelf. Next, we'll go into another double cabinet, but this one goes over the refrigerator and has much more depth than the previous ones. But again, following the same workflow, bottom corner, upper corner, we can select a farther out point thanks to our layout sketch, and it will generate it just like the others. Now that our cabinets are complete, I'll show another automation that we can do with the smart features. When we create them, we can add in specialized dynamic patterns so that I can go in here and change the height of my cabinets to a different height, say 48 inches. And we'll see that as I do this, the holes and the shelf will automatically generate for me, keeping a consistent spacing so that I always have the correct shelving and hole pattern regardless of the size of my shelf. Now we'll go ahead and put that back to 36 and move on. With the upper cabinet done, we can continue to do our smart features and create a full kitchen for us. I'll now go ahead and open up the completed kitchen and show you all of the capabilities within an assembly of using the design library. So here we have our completed kitchen, all created by either smart features or as we see our cabinet here that we created with the weldments. Now, smart components are for assemblies, and are parts that we use on a very consistent basis, such in this case, a knob for our cabinet doors. Smart components, we can set specialized mates to them so that when we pull them in, they automatically mate in place based upon the geometry that we're trying to place them in. So here I'll quickly go and move along the entire upper cabinets, placing in the knobs. And so what this allows us to do is we can store in multiple and different types of components that have all of the mates already built in, and we can very quickly add them to our assemblies without having to go in and mate every single one individually, or using the copy with mates. This way is much faster. Automated modeling with smart features and smart components shows us how we can efficiently use commonly used parts by storing them in the design library and having access to them throughout our designs and assemblies. These allow us to quickly and efficiently create our models without the need to remodel every time we have a slight variation in our designs. For manufacturing drawings, SOLIDWORKS gives us all the power we need to get our designs and models into drawings and out to customers or our own shop floor. Utilizing drawing templates as well as exploded views, weldments, automatic ballooning, we have the power to quickly and rapidly create drawings based on our designs without the need to tediously create them. Everything is linked and associated, so as we update or add items and components to our models and design, we are automatically ensured that everything on our drawing is always up to date. Starting with our weldment part, we can create exploded views as a sub-configuration for our default configuration. Within the exploded view, we can go in and move each body or component around as we see fit. Here you'll see the exploded view of our weldment cabinet. With the weldment exploded view, we can now take a look at creating a drawing with the exploded view, as well as a few other views for reference dimensions, complete with a bill of materials. Drawings can be created using drawing templates, which are blank drawings that we create with all of our title block specifications, as well as views and default tables we want to have generate every time we create a drawing. These templates are easy to create. Now we'll see here the completed drawing, complete with a cut list, an exploded view, ballooned, with each balloon automatically linked to the cut list. Now we can go ahead and create more detailed dimensioning on our two sub views. If we want to bring in all of the dimensions that we used to define the part when we created it, we can use model items. This will bring all of the dimensions from our part onto our view. If the parts are cluttered, we can actually select all of them, and using the dimensioning pop-up window, tell SOLIDWORKS to please auto-arrange all of our dimensions so that it clears our view for easy access. But for this drawing, all we need are the reference dimensions. So we can go ahead and remove the model item dimensions and just using smart dimensions, redimension our assembly reference dimensions. Now that our drawing is complete, we can go ahead and save this out as a PDF, or we could save it out as an eDrawings and send this to non-CAD users. SOLIDWORKS allows us to create multiple sheets if we have more detailed views that we need to create, and we're able to really dive in and make our views and drawings exactly as we need them for the manufacturing world. With the capabilities to always maintain our documents, whether it be the associativity or the views and weldment cut list links within the drawing itself, SOLIDWORKS ensures that we can maintain document control and consistency throughout the drawing process, allowing us to confidently send out our manufacturing documents to customers and to our floor ready for manufacturing. With optimized nesting, we'll take a look at the nesting software integrated directly into SOLIDWORKS called NestingWorks. Here we'll see how we can take a multi-body part, allow NestingWorks to break it into assemblies for us, then setting our parts parameters and our sheet parameters, we can preview and then generate a full nested assembly ready for our G-code. Using our weldment part again, we'll take a look at NestingWorks. NestingWorks is integrated directly into SOLIDWORKS, so we'll go up and activate it through its tab. Creating a new nesting job, we will be prompted to split our multi-body part into an assembly. NestingWorks will do this for us, and then we'll be able to get access to the NestingWorks dialog window. Here we have all of our parts broken down into their individual components in this list. Now we need to go through and set the grain direction for each part. So I'll go through and set each horizontal part as an X direction grain and each vertical part as a Y direction grain. Then we'll also set the material as well as the quantity that we want to create, which we can control on a top level. Once all of this has been done, we can then move on to the actual sheets that we'll be using to nest and cut out of. Going into the next tab, we will add the sheets that we need based upon the thickness of our parts. Once we've added all the sheets, if we try to add another one, NestingWorks will prompt us letting us know that there are no more sheets available for creation because of our existing thicknesses. This allows us to ensure that we do not accidentally create more sheets than are actually necessary. Now, setting the grain direction for our sheet, as well as the number of sheets and the size of sheet that we wish, which we'll do a 96 by 48 standard size, we can then progress into our final options for NestingWorks. Here we can set part-to-part distance as well as part-to-sheet distance. We can ignore the part thickness if we wish to. We can also save outputs as DXF and generate different parameters and requirements. We can also change the type of nesting, whether we're doing a fast nesting or an optimized nesting, depending on the time restraints that we have. Here we'll be using just a fast nest. Once we have completed all of the options, set our material grain direction, as well as picked our sheets, we can then go ahead and preview our nest. Once the preview has been generated, we can see all of the sheets as well as how the nesting will create the final assembly nesting models for us. Now that we have clicked through these and seen all of the different sheets that we'll get, if we're satisfied with this, we can go ahead and create the assembly nest from this. We'll go ahead and do that now, and we'll see all of the sheets generated. Once the sheets have all been turned into their assembly models, we're also given a text document that gives us more information into what NestingWorks has just provided us, so that we can potentially print this out and give it to a manager, or just a quick and easy reference to know that everything was included and we're ready to move on to our next step, the CAM solution. With NestingWorks, nesting is made easy, allowing us to break down our parts quickly and efficiently, select and create nested assemblies that we can then move in and go directly into our CAM solution. With SOLIDWORKS CAM, we have the CAM solution integrated directly into SOLIDWORKS. This allows us to take our NestingWorks directly into SOLIDWORKS CAM. Here I'll show how we can easily pull out the machinable features, how we can easily set our stock and coordinate system, and finally we'll take a look at the tool simulation that SOLIDWORKS provides so we can dive deeper and have a better understanding of the G-code we're going to create. With our nested assemblies, we can now move into SOLIDWORKS CAM. Here, all of the parts have been pre-added for us by NestingWorks, and we can recognize machinable features and allow SOLIDWORKS CAM to analyze the assembly and create the operations as well as select the tools for the job. All of this can be based upon our technology database, or TechDB, which comes with SOLIDWORKS CAM. We can customize this and make it just the way our company or organization needs, so that we can expediently create our G-code. With our features extracted, we now need to set the stock as well as the coordinate system. To set the stock, we can do this by a number of ways, either based upon a pre-existing part, a bounding box, or a sketch. In this case, we'll use the sketch generated by NestingWorks that represents the sheet size. Next, we select the top of the assembly to set the thickness of our stock, which will be the same thickness as our parts. Again, there are many options we can do to set our coordinate system. In this case, we'll set it based upon the bounding blocks of our stock and set it as the upper corner of our stock. Now that we have our stock set, our coordinate system set, and all the machinable features extracted, we can now simulate the toolpath using Simulate Toolpath. Here we can get a visual representation of how the G-code will be created and see the depth as well as the path that will be taken. We can do further investigation by stepping through the process, operation by operation. This allows us to really dive into the G-code that we're going to be creating and make sure that it is operating in the way that we want it to be. We can also take a look at a stock versus final comparison to make sure that everything was cut the way that it needs to be and to the detail and precision that we want. With SOLIDWORKS CAM, we saw how easy it is to extract the machinable features, how we can easily use what NestingWorks created to set our stock and coordinate systems, and how we can delve deep into understanding the G-code that will be created using the Simulate Toolpath. And all of this is capable with having automated CAM built directly into SOLIDWORKS. And so to review, with intelligent design utilizing weldments and equations, we save time in our design and modeling applications. In automated modeling, we saw how with smart components and smart features, we have an efficient use of commonly used parts, all stored directly in the design library. With manufacturing documentations, we saw how using drawing templates, weldments, exploded views, and having the associativity between all of these allows us to maintain document control and consistency. NestingWorks allows us to have a quick and easy nesting operations integrated directly into SOLIDWORKS, and allows us to generate nested assemblies without leaving the application. And then finally, we saw in integrated CAM how we have an automated CAM built directly into SOLIDWORKS with SOLIDWORKS CAM that allows us to easily pull out the features, set the stock and coordinate system based upon NestingWorks assemblies, and to delve deep into the G-code with the tool simulation. All of these capabilities combined allow us to easily and rapidly create cabinet and furniture designs, having all of our parts stored and automated as need be, consistently controlled throughout our company so that we can make the best products we can for our customers. Thank you for attending this webinar, and until next time, keep on modeling.